Hi everyone, in this video we're going to break down how lucky the Oilers got to win 16 games in a row. If you're new here, I'm a certified math and physics teacher in Ontario who holds a master's degree in statistics. So if you didn't know already, the Oilers are now tied for the second longest win streak in NHL history. They won 16 games in a row, where the Pittsburgh Penguins are at first with 17 wins in a row. And obviously they're a good team this year. They dominate most games, but still it's very impressive and unlikely that you win 16 games in a row, especially given that hockey's super noisy. It's one of the noisiest sports ever. It's very hard to predict. So the goal of this video is really to determine how much skill versus how much luck did the Oilers get to get their NHL record. And as always, all the links will be in the description below and timestamps as well, so make sure to check that out. So the first thing we did is we looked on MoneyPuck, and it's a website with a bunch of stats, and again, the links will be in the description below. But the cool thing they have here is that they have all the shots, which you can download, and it has mathematical models that gives a chance of scoring. So each shot has this one has a 4.9 chance of scoring. Obviously, shots near the net go in more often, so it'd be 30.5, 17%, 11.2%. And based on these shots, they generate or simulate a bunch of games. So in this case, they simulate 1,000 simulations, and then they calculate how many times the Oilers got more goals than Vegas. And this game in particular is a game that the Oilers lost to break their streak. So if they won this one, they would have tied for first. And in fact, they had 74.5% chance, according to this particular simulation, of winning the hockey game. So 3 times out of 4, the Oilers would have came out on top. And when you hit refresh, it re-simulates, but it's random data, right? The hockey is noisy again, so they might not come out on top. But here, after another 1,000 simulations, it's instead of 74.5, it's 75%. So you see that the estimate hovers a bit, but it's fairly stable, right? 1,000 simulations is a lot of data, and the Oilers just play one of those games, right? That's the tricky thing. In hockey, you don't play 1,000 games to see who's better. You only play one and let the dice roll, right? So we can still use simulation to estimate luck. So the Oilers lost this one, right? They were one of the 250 games out of the 1,000 that they lost, but most of the time, 3/4 of the time, they would have came out on top. So I did this for all of the 16 games of the Edmonton Oilers, and here are the dates. And then I simulated the 1,000 games 5 times. And we can just take the average, because you can see that most of the time they're close, right? 61.1, 58.9, 58.4. It's very close. And then you can just take the average. So I'll do this video in Google Sheets just for demonstration purposes. But I did the analysis in R, which again will be linked below. So we'll just take the average value of these things. It's 58.8. So this is another way to reduce the noise. And essentially, this is 5,000 simulations. So on average, in the 5,000 simulations, they won 588 per 1,000, right? And then you can just take the average of all the 16 games. You see that most of the time they came out on top. So we can also calculate the overall average win probability. So we'll just go average again. And then we'll select our data. You see that the Oilers on average had 63% of winning a game, which is more than 50-50. So first, we'll calculate the theoretical probability of winning 16 games if it was 50-50. So if the Oilers flipped a coin every game, what's the odds that you get tails 16 times in a row? So again, in Google Sheets, you always need the equal sign when calculating. So it's 0.5. And then times 0.5, because it's independent events. We can take that for granted, even though it's not really true. And then it would be to the 16. And you see that's pretty much 0%. And let's add a bit of precision here. So that's 0.002, which is the same thing as 2 over 100,000. That's 10,000, 100,000. Let's just increase the precision So you see that this is 2 over 100,000. So if the Oilers were to flip the coin 16 times and they were to repeat that 100,000 times, they're expected to witness a 16 heads or 16 tails streak 2 times out of 100,000. That's super unlikely. But the Oilers don't have a 50-50 chance every time. The first game they had a 58% chance, 70% chance. Here they were less likely. So we know that they have an edge, right? They have about a 13% edge, so it's not a fair coin. So how do we calculate the actual theoretical probability? Well, we just multiply all of the win probabilities. So it's not prod, it's product. There you go. And then we multiply all the probabilities. Again, it's unlikely, but let's increase the precision. And you see that it's 0.03%, which is the same thing as 3 over 10,000. So that's in order of magnitude higher. Instead of 2 over 100,000, it's 3 over 10,000. So that's 10 times more likely because the Oilers have an edge. Now, is that likely to happen? No, it's still less than 1% chance. So the Oilers did get very lucky. What's neat with Google Sheets as well is that we can generate random numbers. So for example, if we just take the rand between part of this function, you can generate random numbers between 1 and 1,000. And every time you change the value of a cell, it generates a random number. So what we did in this formula is that we generate a random number. So it'll be 552 in this case. And if this random number is less than the number of wins from the meter, so for example, here you won 588 times out of 1,000. So if this number is less than 588, then that's a win. And if it's more, then it's a loss. So let's just generate a couple of times. And eventually the Oilers will will lose based on this simulation. So 1 is a win, 0 is a loss. So then if you put dollar signs, you can drag according. So let's just check this one, for example. So that's Q1 and that's good. And then let's just drag all of this. So essentially we're playing 16 games and we can count the number of wins by just adding all of the ones and zeros. And in the first replication, we got 9, well, the Oilers got 10 wins, 11 wins, 10 wins, 9 wins, 10 wins, 8 wins, 11 wins, 7 wins, 9 wins, 10 wins, right? So what we see based on this naive simulation here is that most of the time the Oilers will win around 10 games, let's say, but once in a while they'll win 15 and 13, here was 12, 13, twice, 14, and it's unlikely to win 16 games, right? So we can calculate the theoretical probability, which we did. It's I think it was 2 over 10,000. So if we did this a bunch of times, eventually we'd see it, right? So what I did is I recreated this in R, which is a programming software, and simulated 1,000 simulations or replications of the 16 games. And you see that it's almost never that the Oilers won 16 games. Most of the time they won 10. After that it was 11. And this can be approximated by a normal distribution. This is due to the central limit theorem and so on. And it's the binomial approximation. So you just do the mean as NP and the standard deviation is the square root of NPQ. So again, it's extremely unlikely that the Oilers lose all those 16 games, especially that they had an edge. But it's not that much more likely that they win all of them. So of course there was skill involved, but we have to be honest that the Oilers did get lucky, and that's why we witness history, and it's so rare that it happens. Even if you do dominate most games, you're gonna lose once in a while. That's just how noisy the game works, and that's what makes sports beautiful. If you have questions about the stats and the method, feel free to comment below. And as always, thank you for doing the work.